Hello everyone and welcome back to OpenGL. Today we're going to be integrating our collision model and collision mesh classes with our traditional or with our larger model and mesh classes so that we can then put all this stuff in the octree and then start looking at collisions with the entire with the updated models and meshes, which will be more accurate. Alright, so we're just going to be going through, this is going to be somewhat of a tedious episode. There's not much thought that goes into this. It was just how to integrate it, what pointers needed to be where, and this may change once we get further into putting this stuff in the octree. So we'll start in the collision model class, which we simply have an empty body for right now, and we're going to add a few things here. So we'll start by including vector. So the list vector, simply because we're going to need to have a list of collision meshes. And then before the collision model class, we will have a forward declaration for the model class. This is simply to avoid a circular inclusion. So we'll just say class model, no curly braces, just a semicolon. And then in the collision model class, we're going to have a reference to the attached model or pointer. So model pointer model. Then we will have a list of the collision meshes. This is very parallel to our current model class. So standard vector of collision meshes, and then we'll have a constructor that only takes in a model pointer. So collision model is the name, and it will take in a model pointer model. All right, just like that. And then in collision model.cpp, we just want to have one include for the model class, so the model header. So include wherever it is. For me, it's / graphics / objects / model.h. And then I'm going to have the constructor here that we had in the header file. So collision model : collision model takes in a model pointer as a parameter. And then we'll just have an initializer list setting model to model. Just like that. All right, simple enough. All right, next we're going to move over to the model, the other model class that we already had implemented. This is with all the messy shit that we have over here. And we will start with a new include. We're going to include the collision model. So I'll just have it right near the rigid body include. So it'll be include .. /physics / collision model.h, or wherever your header file is there. And then we will have in the class we're going to have a new attribute here. It's going to be a pointer to a collision model. So essentially the collision model and the model will point to each other. I just found that this would be the best way to implement it. So it's just kind of it's somewhat like a double. It's like a double linkage between two objects. So we will have where is it? Where's the fucking pointer? Oh, here it is. Okay. So we'll have a collision model pointer, and I'm just going to name it collision. I'm actually going to put this down with the meshes and the bounding region over there. All right. And then we're going to have 3 new methods. So the first one will be enable collision model. So I will have this over here underneath load model. So this will be a method to just enable a collision model. So just allocate memory to the pointer. So enable a collision model. So it's going to be void enable collision model, no parameters at all. And the second one is going to be, we're going to have 2 new methods for the mesh. So we will have a protected method named process mesh. We're going to overload the process mesh. So it will be process a custom mesh, and this is going to be different from the other process mesh function because this will be taking in vertices as a float array rather than from an object file. So we'll have return type mesh. It will be process mesh, and we're going to have a boatload of pointers or of parameters. So we'll start with the bounding region, BR, then an unsigned integer number of vertices, float pointer vertices, unsigned integer number of indices, unsigned integer pointer number of pointer indices. So this is just stuff that we've seen before in files like the cube.hpp and plane.hpp. Then we're going to have a boolean to determine if we should calculate the tangent vectors. So bool calc tan vectors, and this is going to be equal to true by default. Then we'll have unsigned integer number of collision points is equal to 0 by default. Then a float pointer collision points is equal to null by default. And then, so these are now going to be the parameters for the collision model. And then we'll have an unsigned integer number of collision faces is equal to 0, and unsigned integer pointer collision indices is equal to null by default. And then finally, boolean pad is equal to false by default. Just that parameter that we had trouble with a little bit ago. But these other four parameters here, the number of collision points, and then the faces and indices, these are just the parameters to the constructor for the collision mesh. So we are essentially just going to pass this on to a collision mesh constructor here. And then finally, the last new method will be to add a mesh. This method will just simply add the mesh and then also add the bounding region, because in some instances, or whenever we have a collision mesh, we want that collision mesh's bounding region to overwrite the bounding region for the existing we wanted to overwrite the existing collision mesh that was, or the existing bounding region that was calculated with the actual vertices. So we'll just put this over here. So add a mesh to the list. So return type void, and it just add mesh and takes in a mesh pointer mesh. All right. All right, we have these methods. Now let's head over to model.cpp, and we're going to have a few things to do here. All right, I just need to have one include that you may or may not have already. It's just the include to the scene header file. So this you may already have this. I just changed it around just to make sure that the forward declaration to the scene class in here is actually considered as a forward declaration. All right. So we will go into the constructor, and we will change the initialized list. So the ID stays the same. The bound type is still initialized. The switches, same thing. We have a current number of instances, max number of instances all initialized to whatever they are. And then the last thing that we want to initialize is the collision model to just a null pointer, because we don't want it to be enabled by default. So if we were to say, for example, my vision is in say in the awk tree, if we want to determine if we want to do a finer collision check with the collision model, we would say if model.collision, and if that returns true, then a pointer to a collision model exists. But since we're initializing it to default as null, then that would return false by default. All right. Now we're going to do our new method here. So we will start with enable, or what do I want to do first? Let's just copy the new definitions over. So enable collision model and add mesh. So I'm just going to paste the signatures over. And we will start with the enable collision model. Where is it over here? Here it is. So simply we're just going to say if not this dot collision model, or this dot collision, then this dot collision is equal to new collision model, and we're going to pass in a pointer of this to it. And I forgot to add the model class tags here. Alright, like so. So all this logic is if we don't have a collision model allocated, just enable a new one. And this is not enjoying. What's the error here? Oh, is inaccessible. Oh, okay. So in collision model.h, make sure that your stuff is public, just so that the constructor is accessible. All right. All right, for add mesh, what we're going to do is we're going to say meshes.pushback, and then we're going to dereference the parameter mesh, and then bounding regions.pushback, and we will pass in mesh.br, just like that. So once again, the purpose of this is we want to push back the bounding region from the actual mesh. So if the mesh was loaded and we have a custom collision model, we want to take the bounding region that was loaded in with that collision model, or with the collision indices and vertices. All right, and then we will go into process node, which is over here, and we're going to call that new method add mesh, and we will place these two lines where we add the new mesh and the new mesh.bounding region to the lists, and we will just replace that with a single call to add mesh, passing in a reference to new mesh, just like that. So you take the result from process mesh and then just reference it to make a pointer, and then pass that pointer in to add mesh, and now it should be added in just the same. All right, now we're going to do the method with a buttload of parameters here. So this will be the process mesh, the new one. So I'm going to paste this down below, and make sure to remove all the default variable declarations here, because the compiler does not like to see default variables stated twice, because it doesn't know which one to use. So only have your default variables declared in the headers. All right, so for process mesh, we're going to go through a few things here. We're first going to start by processing the vertex array. So my goal with this method is to take everything that we have in plain.hpp, so pretty much all of this right here, and condense it into one method. So we're going to call genList, we're going to call calculate the tangent vectors, and then we're going to load the data into the mesh, load the collision model if it exists, and so on. So we'll start with process vertex array. The standard vector of vertex list is equal to vertex.genList, and we're going to pass in the vertices and the number of vertices. This is the same set that we have called before. We're going to create the index list. So standard vector of unsigned integers, and we will initialize it, or I'll call it index list, and I'll initialize it with the size of number of indices. Now we're going to do a little thing. We're going to say if indices, then we're going to copy an array. So since the pointer exists, we just want to copy the array into the index list data. So memcopy index list.data, and that's a method, and that's the destination. The source will be indices, and the size will be number of indices times the size of an unsigned integer. So what is this? What is this method called? So the vector is a dynamic array in the sense that it is a resizable array, but it is an array nonetheless. So the values are stored consecutively. So since we have an array of indices, we can just simply copy that memory over to the index list without having to call indexList.add how many times, which could be very taxing. So we're simply going to take the memory, stored with the index list, or with the index array that we passed in to this method, and we're just going to copy it over to the index list data, which is given by this pointer here. All right, and then otherwise, we're going to assume that we want to give in sequential indices. So for example, in cube.hpp vertices, we want to have them sequentially inserted. So we're going to do something like this, where we just loop through the number of vertices and then insert the index there. So we just want to go through them one by one. So we'll say insert sequential indices. So for unsigned int I is equal to 0, I is less than the number of indices, I plus plus, and then index list at I is equal to I. So we're just going through them one by one in order. All right, and then we're going to calculate the lighting values. This is the tangent vectors. So we'll say if calc tan vectors, we're just going to call vertex.calc tan vectors, pass in the vertex list and then the index list, just like that. All right, now that we have assembled all the vertex data, like we do in plain.hpp, so we're up to this point essentially, we want to call the mesh constructor and then allocate the data there. So we'll say mesh ret and call it with a bounding region. This is a constructor that may not exist. I don't think it exists yet, but we will be creating a few new constructors for the mesh class, which will allow us this constructor to be valid. And then we'll say ret.load data, and we will pass in the familiar parameters, so the vertex list, the index list, and then we will pass in the parameter pad, which was passed into this function here, right here. All right, and then after we load all the data, we want to allocate the collision mesh if necessary. So if number of collision points, so if that's greater than, if that's a value not 0, then we will enable the collision model. It's not like this. Oh, because I never added the model class tag. Yep, that always happens. IntelliSense was not working. So we're going to call the method that we just created enable collision model, which will allocate the memory, and it will only allocate the memory to a new collision model if one does not already exist. So we don't know if this is our first mesh or or some other mesh. So we're just going to call this method, which may or may not allocate new memory. And then we're simply going to say ret.load collision mesh, which is another method that we will create. And all this method will do is it will just call the constructor of collision mesh. So we're going to pass in the 4 parameters, which will be number of collision points, the number of collision faces, and collision indices, just like that. So once again, these are the 4 parameters that will be passed into the collision mesh constructor. And then at the end, we can just say return ret. Okay, that looks good for the model class. Now we're going to move over to the mesh class. All right, so we'll start with a few new includes, or just, I believe it's 1 new include, or 2 new includes. So we're going to include the material header file. So include ../rendering/material.h. This just has all the material lighting values. This is just for a maintenance method that we'll be creating. And then we want to include the collision mesh header. So include ../physics/collisionmesh.h. All right, and then in the mesh class, so we'll skip the vertex structure. We're going to start with a pointer to a collision mesh. So we'll have a pointer to the attached collision mesh pointer, and I will name it collision again. All right, now we're going to go through the constructors. We're going to create a new one, and then we're also going to change a few. So we leave the default as is, and then we want to create a new one to initialize with a bounding region. So mesh pointer, or mesh constructor, and it just takes in bounding region BR. Now we also need to, because we have this this constructor, we need to remove the default parameter from the texture constructor, because this parameter does not need to be there, so therefore the two methods would be the same, or could be considered the same, so the compiler would not know which version to use. So just remove that default parameter. And then we're also going to have a new constructor here. So it'll be a fifth constructor. I lied. We're going to have 5 now. We're going to initialize with a material. So mesh, pass in a bounding region BR, and then pass in a material M. So this will just allow us to pass in the color values, which will, it's essentially the same as passing in the diffuse and specular colors, except we can just pass it all in through a structure. All right, then we're going to have 3 new methods here. The first one is going to be to set up the color values, or set up textures, sorry. So void setup textures, pass in a standard vector of texture, and you call it textures, then set up the colors. This will be void setup colors, pass in an AI color 4D diff and an AI color 4D specular. These are methods that I would highly recommend including. They may seem boring now, and they are boring, but it's going to help us a lot when we in simplifying the code in the other classes. And then finally, set up material structure. So this will just be void setup material, and we will just pass in a material structure mat, just like that. All right, and then the last method that we want to include is to load the collision mesh. So this will be a setup collision mesh. So we'll have void load collision mesh, the function that we called in the model source file, and this will just take in the collision mesh constructor parameters. So unsigned integer number of points, float pointer coordinates, unsigned integer number of faces, and unsigned integer pointer indices. All right, so we have several new methods to look at. So I'm going to copy the function signatures, or I'll actually just go through them one by one. All right, so let's go to the to mesh.cpp, and we'll start with the constructor. All right, default constructor. We need to initialize the collision model to null by default. Same reasons as we did with the collision model in the model class. Then in mesh, or we need to create the new constructor that takes in a bounding region. So I will just copy the signature over. Put the tag in, and this will simply initialize the bounding region as a BR, and then also initialize the collision mesh as null, like so. Now, when we pass in the textures to the constructor, the texture list, I'm going to remove the existing initializer list, and we're just going to call the other constructor. So say mesh and initialize it with the BR, so we'll call this constructor right here. And then in the constructor body, what I want to say is just call setup textures with the texture list. And then similarly, for the material object, with the colors, we're going to call the mesh constructor in the initializer list like that, and then we will, in the body of this constructor, we will call setup colors and pass in diff and specular. And then we have one more constructor to do, which is the initialize as a material. So I will copy this over, and it's going to be the same type of thing. So we will call in the initializer list, we will call mesh, the other constructor with the bounding region, and then in the body we will then call setup material and pass in m, or whatever the parameter was in the constructor here. All right, let's have the three setup methods: the textures, colors, and material. So I'll copy these signatures over. All right, for setup textures, I just need to copy and paste, or just put in the class tags to ensure that this is all compiled properly. So for mesh setup textures, we will have this dot no text is equal to false, and then this dot textures dot insert, and we will pass in this dot textures dot end as the where we insert, and then we will insert from textures dot begin to textures dot end. So this dot textures dot end is the insertion point in the mesh class, and then we pass in textures the parameter dot begin to the parameter textures dot end. So that's the textures, and then for the colors, it's going to be similar. We're going to say this dot no text is equal to true now, and then this dot diffuse is equal to diff, and this dot specular is equal to spec. So the parameters. Now for the material, we will just have to call essentially the same, or just assign the same things, except we have to parse the RGB values from the material structure, because the material structure over here stores the color values as a GLM vec3. We could change this, but it's not too necessary. So we will have in setup material, this dot no text is equal to true, then this dot diffuse is equal to, and then in a constructor initializer list, we'll call mat.diffuse.r, mat.diffuse.g, mat.diffuse.b, and then 1.0 as the alpha component. And then similarly for specular, we will just call the same values, but we want the material.specular color. All right, just like that. Once again, these methods will just help us simplify the code in the other files. Now we want to have this last method here, load collision mesh. So once again, I'll copy the signature over. All right, mesh the class tag. All right, for load collision mesh, it's going to be pretty simple. We're calling the constructor. So this dot collision is equal to new collision mesh, and we just pass in the parameters to the constructor as the we pass in the parameters to this method as the parameters to the constructor of the collision mesh. So pretty much the same thing. So number of points, coordinates, number of faces, and indices. The names even match up. And then the other thing we want to do here is copy over the bounding region. So since we have a simplified mesh with a new bounding region, we want to have that bounding region as our collision box or hitbox or whatever. So we'll say this dot br is equal to this dot collision dot br. All right, so that's all the code pretty much. Now we just have to kind of integrate the rest of it into our existing classes. So we'll start in the plane.hpp, and we're just going to change around some of the code in the initializing method. So in plane.init, you can pretty much delete everything after the bounding region. So we have our bounding region here, and then we're going to create our mesh. So mesh ret is equal to process mesh. We'll pass in, we're going to use the custom mesh function, the overloaded one, so pass in br. The number of vertices will be number of vertices, and then quad vertices there. Then the number of indices will be 6, and the index list will be indices. And also, you should make the index vector into an index list, so, or an unsigned integer array, rather. like that. So yeah, we want this as a pointer now, so we don't want it as a vector. So indices there, then we want to calculate the tangent vectors. Then for our collision, what's nice about this model here is that everything here is pretty much the same. The only difference is we can't use this array directly. I'm actually just discovering this now. But the reason why is because we have our normal and texture coordinates, so we can only take the position coordinates in a new array. So float position or collision vertices. That's going to be an array, and you can simply copy over the position ones. So in Visual Studio, you can hold Alt, and that will kind of allow you to select a rectangular region without selecting whole lines. So that's how I'm doing this here. It's just like that. However, the indices do stay the same. So the rest of the parameters for the process mesh method will be number of vertices, and then for the points we will just pass in collision vertices. And then for the number of collision faces, make sure not to pass in 6 because that's the number of indices. The number of faces is just the number of groups of indices, so it's going to be 2, since we only have 2 indices, or 2 faces, to make up the rectangle. And then the collision indices will just be the index array, so indices. Alright, just like that. And then since we have our textures, we're going to call ret.setupTextures, and we're going to pass in textures. So this is the reason why I wanted to separate it, because in the model process mesh function, we don't care if we have access to textures or colors or whatever, and it would just be inefficient and cluttered to pass in a texture list and have to deal with all the overflows and all that checking that is irrelevant to the process mesh function. So we just want to separate those two methods so that the textures are a separate thing. And then after this, we can just call add mesh and pass in a reference to ret, just like that. Let's head over to cube.hpp and we'll do something similar. So what we can do is we can delete everything after. We can delete the index list, the index vector, and then everything after the bounding region. Alright, so let's now go through our collision model vertices. So we'll do float collision vertices, and that's going to be an array. And what we're going to have in here is we could just copy over all the vertices from here and then just have a sequential list of those. However, a lot of these vertices are repeated. Now you may remember when we first had this cube class and you were wondering, oh, why do we have 36 when we have when we can just index into this list? Well, the reason why is because the normals are different. So for each vertex will essentially have 3 normals because it's present on 3 different faces. And we don't want to average those normals because then it would give incorrect results, really. So what we have to do is we can we have 36 vertices for the model vertices, but then for the collision model vertices we can then have 8 and reuse those since there's no normal vector attached. Alright, so we'll do this here. So minus 0.5f, minus 0.5f, and minus 0.5f. So I'm kind of going to count in binary here, where a 0 is going to be negative, and then a positive will be a 1. So 0, 0, 0 is negative, 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 and then we'll do negative 0.5, negative 0.5, and then positive 0.5, and then negative 0.5, positive, negative, and then we'll do negative, positive, positive, and then now that we're repeating, since we have 4 and we have a total of 8 vertices, 4 in the front face, 4 in the back face, we can copy this, and then what we can then do is just delete the negative signs on the x coordinate here, like that. The reason why this works is because the counting for the last two for these two coordinates, the y and z, will repeat in negative and positive. That the pattern there will repeat just based on whatever the most significant coordinate or the x's. This is just principles of binary counting. I'm not going to go into that right now. It's just a little tidbit of information. All right, then for collision indices, unsigned integer collision indices. And then what we're going to do here is we're going to go through these coordinates, and then we're going to just take the index of them, which happens to be since we counted up in binary, at index 0 is essentially our analogy to a negative, 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 or a 0, 0, 0, which is 0 in decimal, and then also 0 in binary. And then this, let's say the second value here will be a 0, 1, 0, or a 0 or a 2 in decimal, which is our index. And then what I did was I just went through the vertex list that we have here for each of the faces, with the one with the 36 vertices, and I just kind of matched whichever one. So for example, the first position in the vertex list is a negative, 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 so it's a 0, 0, 0, so index is 0, and I just did that the 36 times. So we go, I'm just going to say it out, so 0, 4, 6, then 6, 2, 0. I'm realizing now I should have a copy paste, or a I forgot what, a paste bin, but it will be on the GitHub after. Then 1, 5, 7, 7, 3, 1, then 3, 2, 0, 0, 1, 3, 7, 6, 4, 4, 5, 7, 0, 4, 5, 5, 1, 0, and then 2, 6, 7, 7, 3, and then 2. And you might notice some patterns here. This is just rectangular, so each of these is a face, so we have a total of 4 different vertices. So for example, we have a 0, 4, 6, and a 2, and then that's a total of 4, which makes up our rectangle. All right, so those are our collision indices, and now we can call the same, the process mesh method, then the setup, and then add the mesh. So we'll say mesh ret is equal to process mesh, pass in the bounding region, because we're calling the overloaded one. The number of vertices will be number of vertices, and then vertices there. Then we will, for the number of indices, it will be null, or wait. The number of indices will be the number of vertices, since we're going to be counting sequentially, and then we pass in null as the indices. Because in process mesh, if you remember, we have this little thing here, if indices. So if we pass an array, we want to copy the array, which is what we did with the plane. However, since we just want to have it sequential, we can just not pass in an array or pass in a null pointer. So that's why that null is there. And then we want to calculate tangent vectors, so true. Now for our collision points, we're going to have 8 of them. The number, that's the number of collision points. The collision points array will just be collision vertices, that array that we just created. And then for the number of collision faces, be careful here. We're going to have 12 collision faces, since we have 6 rectangles on a cube, and each rectangle is made up of 2 triangles, so 12 of those. And then collision indices is that list there, or that array. And then we want to set up the material, since the cube is considered as a material, so ret.setup material, pass an m as the material, which is something that we pass in with the constructor here, so it's right here. And then after this, we can just call add mesh, the inherited function, passing in a reference to ret. Just like that. And let's build it. Woohoo! Alright, let's run this. And everything should look, so make sure that you delete the return, because we were testing this and we didn't want to start any window, so we just put a return before that in the main method, so just remove that. And everything looks the same. Once again, I don't know what's up with this lighting. It has to do with, it was screwing up on the sphere as well. So I will look into whatever the problem is, and I honestly have zero clue. I'm going to be 100% honest with you. I have no clue what the problem is, but I will look into this, and maybe I'll figure it out. Maybe I won't. I probably won't, but eventually I'll post some video about it. But yeah, so that is our integration into the of the collision models into the model and mesh system that we have currently. Next, I'm going to be working on moving this stuff towards the octree, and then we will then integrate the collision testing with the octree and all the possibilities in that case, and then also the transformations with the rigid bodies, which will be fun, and that will be more algorithmic in this video. So thank you for watching. Hope you learned, or there's not much to learn here, but hope you found this useful, and yeah, stay safe, and I'll see you whenever. Have a good one.